Welcome back, class. So we are learning about the loop or mesh analysis, and now we will look at an example of supermesh. So if you guys can recall from the nodal analysis that we have learned that whenever a voltage source is connected between the two nodes, that actually become a super node. So same concept is applied here, okay? So when a current source is basically connected between two loops, it will become basically a supermesh. For example, if you look at this circuit, we basically have three loops, number one, number two, and this is the third loop. Okay, so the first thing is always, okay, we will define the loop current. So I can say that first loop current is, let's say, I1, this current is, let's say, I2, and this current is, let's say, I3. Okay, so and this is an independent current source, so it means I can directly write the value of this loop current. That will be I1 will be is equal to 2 milliampere. Now we are left with the loop 2 and 3. Now here we need to pay attention. Okay, we can say that we have another current source, and this current source is basically shared, connected between the loops 2 and 3. So like as we did for the first loop, okay, because it was independent and this current source was not shared between the two loops, so we write the loop current directly. Now we cannot write like this current 4 milliampere. I cannot write that will be 4 milliampere, or it will be I3 will be 4 milliampere. We cannot do that. Okay, because this loop, this current source is shared between these two loops. Okay, so whenever we have this such scenario, so this basically will make a super mesh. Okay, this thing will make a super mesh. Okay, so in super mesh we will use the similar approach like we did in the node cases. We will write one equation, okay, for the super mesh. So for example, this is the 4 milliampere. So this is shared between I2 and I3 loops. So I2 is flowing like this way, and I3 is basically coming like this way. So I can write basically, because the direction of the current is towards I2, so I can write like I2 minus I3 will be equal to 4 milliampere. Okay, so this is my super mesh equation actually. The current source equation that basically is making a super mesh. So first of all, we will write this equation. Okay, after that we will take that current source, okay, and we will remove it from our circuit. So if we remove that from our circuit, so then our loop will become of both loops. Okay, what does this mean? For example, if I start from this end, okay, so this will go to this side, and now I come here. So because this has been removed, so I can go towards this side, comes this side, this side, this side, and this side. Okay, so that basically will make my current loop. Okay, now for this case, so this is basically my super mesh. Okay, now let's try to write the equation for this super mesh. So we can start from any one point. Okay, for example, this voltage source. So I can say that it will be basically what, minus 6. Then the voltage drop here. So this is 1K multiply what is the current flowing through this one, I3. Okay, after that I reach, okay, I'm following this one and I reach here. So what will be the drop here? Plus 2 times of what is the current flowing through this resistor? Only I2. Okay, then we reach here. So it will be again 2 times of. Now through this resistive branch, two currents are flowing again. One is I2 and one is I1. So we can write this as I2 minus I1. Okay, so because our reference is I2, so that's why I2 minus I1. After that, I reach at this point, so it will be plus 1. Now what is the current flowing through this one? Again, two currents. One is I3 and one is I1. Because our reference here is basically super mesh, so we can say that basically current through 1 kilo ohm will be I3 minus I1. Okay, and we reach to the starting point. So this is basically the equation of the supermesh. So remember, in the supermesh, we will remove the current source which is shared between the two loops and write the equation for that. And after that, those two loops will be combined together to make a bigger loop. And we write the equation for that. So basically now here we have two equations and two unknowns. Okay, I1 we already know that. We need to find I2 and I3. Okay, so and this equation also contain basically I2 and I3. There is a I1 variable, but we can put up the value. So let's rearrange it, okay, to get the better one, better equation form. So we have minus 6 I3. Again, I'm not putting K because K will change the currents to milli, okay, at the end. So 2 times of I2, then 2 times of I2 and I1. Okay, so what is the value of I1? 2 milliampere. So I can put that here. So 2 times 2 minus 4. Then plus I3 minus I1. Again, minus I1 is 2 is equal to 0. So we have 2 I2 and 2 I2. So that will be 4 times of I2. Then I have this I3 and this I3. So that will be 2 times of I3. So what are the constant? Minus 6, then minus 4, minus 10, and this minus 12. So that will be minus 12 and goes to the other side, become plus 12. Okay, or I can simply write this equation as if we divide it by 2. So 2 times of I2 plus I3 is equal to 6. Okay, so basically this is, I can call this equation 1. This is my equation 2. Two equations, two unknowns. Okay, let's for example do the substitutions. For example, if I say that I3 will be basically can be written as I2 minus 4. Okay, you can use either one. Okay, I2 and I3. So for example, I3 could be I2 minus 4. So let's substitute this here. So what we have here, 2 times of I2, what is I3? Plus I2 minus 4 is equal to 6. So 2 and plus 1, that will be 3. So 3 times of I2, so 6, this will go to the other side, plus 4. So basically I2 will be 10 divided by 3 milliampere. Okay, now we can plug this one back in this substitution equation to get I3. So what will be I3? I3 will be I2, which is 10 over 3 minus 4. So this will be 10 minus 12 divided by 3, or basically minus 2 over 3 milliampere. Okay, so we got the value of I1, we got the value of I2, we got the value of I3, all loop currents. So what was the question here? Question was to find the I naught. So I naught is basically the current flowing through this 2 kilo ohm resistive, okay, branch here. Yeah, this is I naught. Okay, so I naught can be written as basically simply how we can write that, which value is bigger here? I1 is bigger, right? So and the basically direction of current is downwards. So we can write this as basically I1 minus I2. Okay, so I naught could be written like this way. Okay, because like I1 is basically coming this way and I2 is basically going this way. So actual direction is downward, so that's why I wrote it I1 minus I2. So what is the value of I1? 2. What is the value of I2? Basically 10 over 3. Okay, so what we will have here? We will have here 6 minus 10 divided by 3. So basically minus 4 over 3 milliampere. Okay, so this way we can find the value of I naught. So the learning from this example is like you need to identify if there is a super mesh in your circuit, then write a separate equation for that source only, and then write a super mesh equations like this, and then just like follow the simple approach to solve those equations and to get the values of I1 and I2 and I3 for this case. And lastly, just find whatever desired output for variable you need to find out based on the values of the found currents. Thank you so much.